All right, so today, I'm glad there's not too much of an overlap between Tim's talk and my talk, because his talk was much more colorful. Mine's more, just black and white. Anyway, so the title of my talk is it chance? Is it chaos? What's the difference? So let's see. Well, first of all, we need to look at a definition of chaos. So we're going to go to the next 3 slides, which are very boring. And we're going to the fount of all knowledge, Wikipedia. So here is, according to Wikipedia, a definition of chaos. A lot of stuff here. Chaos is a branch of mathematics focusing on the behavior of dynamical systems. Everybody knows what that is, right? That are highly sensitive to initial conditions. There we go. Chaos is an interdisciplinary theory stating that with the apparent randomness of chaotic complex. Are you already lost? I pretty much am. Okay. So, yeah, the point of this story is, and maybe it's in the next slide, is that even with systems that have some analytic predictive value, there are things that can happen with just small little changes that can drastically change the system. So we're going to look at some examples, and specifically we're going to look at Hurricane Florence. You remember Hurricane Florence? It wasn't that far long ago. So there were some interesting things that happened there. So that's probably more than you want to know. So we're going to look at something different. So let's see what's going on here. Okay, we're first of all going to talk about determinism and non-determinism, because that kind of is the basis of some ideas about chaos theory. A deterministic process is a process that gives us a single answer in a given situation. For example, if I throw a ball up in the air with from an initial height of, well, here's about 4 feet, I'm about 5 feet tall, with an initial velocity of 16 feet per second, what happens? Can somebody just describe what's happening here? Yes, sir?
A falcon swoops in.
No. Right. Thank you so much.
Yeah.
Who wants to precisely describe what's going on here? Yes, ma'am.
The ball accelerates going up, and then it reaches a point, and it stops, and then it accelerates downward at the same speed that it accelerates.
It does. It decelerated, yeah. So it goes up, and as it's going up, it slows down. It reaches a tiny little pinpoint at the top where it actually stops, and then starts back down again. Now, is there any way to precisely describe that? Well, of course, teachers never ask a question unless they're going to pose an answer. So yes, there is an equation that precisely gives the position of the ball at each point in time, which is represented by t. Here's the equation. S of t, that's how mathematicians say that. S of t is equal to minus 16t squared, because that was the initial velocity, plus 16t plus 4, where t is the time in seconds, and S of t, that whole symbol, represents the position of the ball at any point in time. So if I want to know the position of the ball at a particular point in time, I just plug in that t value in the equation and do the math. Everybody can do the math, right? Do the math. And my answer gives me the exact position of the ball at that time. There's no deviation from that. Every time I plug in that same t value, I get the same answer for the position of the ball. So for each value, I'm repeating myself here. So for each value of t, there is a single answer for the position of the ball, and that answer is the same every time I plug in that value of t. This is what's known as a deterministic process. There's only one answer to a specific situation. Philosophically, determinism is a point of view that says all processes in the physical world are deterministic. This is from this book. Does anybody recognize any name in that book, in that title? Who was our main speaker? Russ Howell. Okay, well yes. This is Jim Bradley at Calvin. This is Russ Howe at Westmont. Mathematics Through the Eyes of Faith, published by Harper One, but it's a CCCU book. And if you don't know what CCCU means, well, just ask anybody. They'll tell you. Right. Okay, so that's determinism. Give me an equation, plug in a t-value, get one answer, and I get that answer every time. How about non-determinism? A non-deterministic process is a process that gives us multiple possible answers to a given situation. If I give Edward Jones $1,000, well, my account may go up, or it may go down, or they may give me a range, could go up to 2.5%, or could go down to minus 18. I mean, they're going to give me some possible answers with maybe even some probability based upon you. Okay, never mind. All right, so let's take a simpler example. I'm going to roll a die. Yes, we're gambling. Love math. Rolling a die. 5. Is that what I got? Thank you very much. Okay. Rolling a die and noting the outcome. What happens when you roll a die? What can happen?
You have six chances.
You have
6 different chances. So
yeah.
1 out of 6 chances of getting a 1.
Oh, you're good. You should take more math. Yeah, you have 6 different possible things that can
I
happen.
need more math.
You need more math. Very good. Hallelujah.
I'm having math this semester.
Oh, well, we need to talk then. Okay. So there's any one of 6 things that can happen, and as she eloquently said, each one has the same chance of happening as any one of the others. That is, if you're playing with a fair dice, that is. Some places don't. Yeah, okay. So I can reasonably be sure that I'm going to get one of the 6 possible outcomes, and that each of these possible outcomes has the same chance or probability of happening. Now, there is a book, I think it's called How to Take a Chance, or maybe it's How to Lie with Statistics, that says, well, those aren't the only things that could happen when you roll a die. If you roll a die, a bird may come along, as you so eloquently say, a bird may come along and carry it away. Or there might be a nuclear explosion and the die will melt. Or any of a number of things, okay? Anything could happen. But the point is, there's not just one thing that could happen. There's 6 things. One of 6 things could happen. All right, so for deterministic processes, there are multiple possible outcomes that can happen. Oh, I don't know how to spell the word can, do I? That can happen. And one must take into account these possible outcomes. Philosophically, non-determinism is a point of view that says, well, not all processes in the physical world are deterministic. Maybe some of them are, but not all of them are deterministic. Again, from Bradley and Howe, page 96. Oh, in case you don't know what the book looks like, it looks like this. My copy isn't autographed. Tim's is. I missed my chance. Okay, let's talk about uses and misuses of the word chance. This really gets me. Okay, in mathematics, chance and randomness are defined as non-deterministic since they're associated with processes that have multiple outcomes. And each outcome associated with a specific process has a number associated with its chance of occurring, and that number is called its probability. And in this sense, this is a mathematical sense, these types of processes are considered purposeful. We know what's going to happen. We don't know exactly the specific thing that's going to happen. How does this idea of chance and randomness differ from how we use the words chance and randomness in everyday life? When people use words like chance and randomness in everyday life, they're often referring to a process that has no purpose, or at least they can't figure out what the purpose is. It just suddenly happens and it took them by surprise. For example, someone may say, well, that happened by blind chance. We heard that phrase last night in Dr. Howell's use of the word blind chance, and it kind of grated on me because I don't think those 2 words go together. That's just me. What they usually mean is that there was no reasonable explanation in their mind for why it happened. In other words, it was not purposeful. They're not referring to a process that has multiple outcomes, where each outcome has a probability of happening, and therefore it's purposeful. Or if they are, they're unable to specify what those different outcomes are, or the probability associated with any of those outcomes. To a mathematician, chance and randomness are not processes without purpose. A process that has multiple possible outcomes, specific multiple possible outcomes, each with a probability of occurring, is very purposeful. And thankful for that, because that means I have a job. Okay, another misuse of the word chance. Sometimes people say that something was caused by chance. This is a pretty picky point from mathematics, but chance does not cause anything. It may describe what happened. It merely specifies the different outcomes in a given situation and the probability of each of those outcomes occurring. But when people say that something was caused by chance, what they usually mean is they don't understand why they got the particular outcome they got. So they'll say it was caused by chance, or it was blind chance, or whatever. In fact, and this is again from Howell and Bradley's book, knowing that something is caused can rule out chance. That is, if A is the cause of B, in the sense that whenever A occurs, B must follow, then chance is not part of the relationship between A and B. It's a completely deterministic sort of thing. So when someone says something was caused by chance, they're not thinking about different possible outcomes that occur, nor are they thinking that the particular outcome they experienced is one which had a specific probability of occurring. They're not thinking that. Okay, back to determinism and non-determinism. Is the world deterministic or non-deterministic? Or are some processes deterministic and some other processes non-deterministic? Or do some processes have both deterministic and non-deterministic aspects? And what does this have to do with chaos? Okay, well, we're going to talk about the central limit theorem. Now, there are lots of different versions of the central limit theorem. And I'm not going to give you all of them, but I'm going to show you what one version of it has to say. We're going to look at an Excel spreadsheet. Yay, Excel. We're going to look at an Excel spreadsheet in just a minute, and it's going to show you a couple of different things. First of all, among individual events, there can be differences, but if you look at all those individual events together, there is uniformity. There is a pattern. And Bradley and Howe call these two different things randomness at a low level and orderliness at a higher level. So let me show you some data here. Okay, here is an Excel spreadsheet. This is what makes my heart just go crazy. Okay, so here we got, okay, Bruce here, Dr. Baldwin. I have randomly generated some numbers from 1 to 10. I've randomly generated 30 of them specifically for him. He ended up with 3 2s, 5 3s, 2 4s, 6 5s, 3 6s, and so forth.
That's my salary.
That's your salary. Very good. And then Andrew, he is sample 2. I randomly generated 30 numbers between a 1 and 10 for him. He got 5 1s, 6 2s, a 3, a 4, a 5, 2 6s, and so forth. Does his results look like Bruce's results? No, there's differences, aren't there? There's some diversity here. They didn't get the same thing. And then I can go with Professor Wagner. Here's his sample. And then Professor Weekland, there's her sample. And Dr. Rupert, there's her sample. And Maddie, there's her sample. And we can go on and on. Cody, here's his sample. So we all have a sample of 30 numbers randomly generated from 1 to 10. And boy, they don't look very much alike, do they? I mean, these 4 start off perfectly correctly. And then, boom, they just diverge, don't they? There's quite a bit of diversity here. There's some randomness happening. So there's quite a bit of difference here. So this is randomness at a low level. But let's see how many we have. We have 300 numbers here. Let's take all 300 of them. If I randomly generate numbers from 1 to 10 and I do 300 of them, and how much of each number should I get? Larry, come on, you don't know. What was that, Matt?
30.
30. I should get 31s, I should get 32s, I get 33s. Well, we're not too far off. We only took 30 samples, and out of those 300 numbers, we got this is how many we got. And if I make it in terms of a relative frequency or percentage, if you multiply by 100, you get percentage. 10% of these 300 numbers were 10s, 9% were 9s, 11%, 11%. Well, okay, not too far from 10% of each group, is it? I went ahead because, I had nothing better to do in my office. I probably should have gone to a committee meeting, but we blow those off. We don't go to those committee meetings. All right, so I went ahead and did 40 samples with 30 in each sample. So I have a total of 1,200 numbers randomly generated from 1 to 10. And, here I would expect to get about 120. Well, it's not coming out very well, but, the percentages, they're not altogether different from here, but they all sort of cluster around 10%, don't they? So even though I have 10 different samples that all look dramatically different from each other, randomness at a lower level, I've got some uniformity at a higher level. When you aggregate all of those, we have some patterns going on, don't we? We have what we expected to get in an ideal world, right? Okay, so that's one of the many things that the limit theorem says. You're not going to be guaranteed 10% on any given sample, but if you do it often enough with enough different generations of numbers, you're going to get some patterns that occur. Okay, so for me, I don't know if quite a bit of variation. It's a non-determinate, each sample, it looks like a non-determinate process because there's quite a bit of difference from one sample to the other. So that looks kind of like multiple outcomes to me. But if I do all of them together, I get something that looks a bit more deterministic. I'm going to get about 10% every time of each number. So that looks kind of like a mixture of non-deterministic and deterministic. Okay, so what's the point? Okay. Now, Bradley and Howell, in their book, are quoting a man named David Bartholomew, or they write about a guy named David Bartholomew who wrote a book called God, Chance, and Purpose. Can God have it both ways? Meaning non-deterministic and deterministic. And this is a quote from Bradley and Howell. Bartholomew is arguing that God's sovereignty operates in different ways at different levels. It is easy for a believer to affirm that the beautiful order and structure we see at aggregate levels is an expression of God's orderliness and goodness. But, Bartholomew is saying, the seemingly chaotic randomness we see at low levels is also an expression of God's sovereignty. Might be a little unsettling there if you think you have everything in your life figured out at age 19, 20, or 50, whatever. Okay. 55, okay. So general laws with built-in flexibility, that's what these guys are talking about. Bradley and Howell give examples from ecology that show that randomness allows ecosystems to adapt to changes in their surrounding environment without having to be constantly tweaked. In other words, there are general laws that govern the natural world, but these general laws have built into them a sense of randomness so that small changes can happen. This provides a system with flexibility and robustness they need to adapt to changing conditions. This is one of 4 reasons the authors give for why God uses non-deterministic processes. On page 109 of Bradley and Howell's book, you can see the others, or if you're too lazy to buy the book, I made a few photocopies, so there you go. So what does this have to do with chaos? We've been talking about deterministic, non-deterministic. Okay, let's be more specific here. Let's look at weather prediction. There are lots of factors that affect weather and our ability to predict it. We were in Hawaii about 2 years ago this Christmas. It was wintertime for us, and wintertime there, of course, and the temperature ranged between 60 and 80. We were down at the beach, and I said to a lady, "So what's wintertime like here?" And she just looked at me like I was stupid. Of course I was. And I said, "What's summertime like it here?" And she goes, "Well, it's so hot here. The temperature's between 70 and 90. And I just gave her one of my usual dumb looks and said, oh, well, okay. So I'm sure there'll be a time this winter when I'm going to, I wish I was in Hawaii.
Amen.
Anyway, lots of factors affect weather and our ability to predict it. Temperature, humidity, water cycle. Do we live in a desert? Do we live in a humid area? Air pressure, air masses, latitude, altitude, speed, direction, land and sea distribution, mountain plains. Do we live near mountains? Do we live near lakes and oceans? Other desert, for example. Wind, the season, the time of the day, gravitational pull of the moon, amount of sunlight. Well, there's a whole list of things on here, not to be deleted. How soon my lawn needs to be mowed, and the date of our next church picnic. We had a church picnic last Saturday evening, outside. Oops. It was so much fun. Okay, Hurricane Florence. I don't know. I watch the weather every night, and about 2 weeks out, they were saying there's a hurricane over here in the Atlantic Ocean, and it's moving toward us. Somewhere along the eastern border, it's going to make landfall. Get ready. A week later, they're saying it's going to come in somewhere around South or North Carolina. And we think it'll go kind of northwest. Within 2 days of Florence landing, they knew exactly where it was going to land, and they knew it was not going to go northwest. It was going to curve around and hit those poor suckers on New Jersey and New York, right? Now, 2 weeks ago, they knew there was something heading our way, and then a week later, they got a little bit more precise, and then 2 days before the hurricane hit, they got even more precise, because they're saying all these things can change. I can generally predict what's going to happen, and as we get closer, we can predict more precisely, but it's anybody's ball game until we get close enough to the time when it's going to happen. Many of these individual factors have precise mathematical models or equations. I love it to watch Dave Andrews on Channel 6, because he'll say, well, one of the models says this is going to happen, but one of the models says this is going to happen. I'm going, oh, just tell me, is it going to rain tomorrow or not? He doesn't know. These equations, while providing good information about what is likely to happen with the weather in the next few weeks or days, they've involved parameters that can change. For example, oh, I love this one. The sine graph. You know, sine graph? Yeah. I could say sinusoidal and really sound fancy, but it's just the sine graph. Provides a model for high temperatures over a year's time. You start in the spring and the temperature rises and then it goes down, and you know what happened. Oh, it'll start, yeah. And then it goes down in the wintertime and comes back up. There's a nice sine curve. Okay. All righty. Does this mean that the equation can exactly predict the high temperature for a specific day in a different year? Probably not, since there are lots of factors that can affect temperature on a given day at a given time of the year. This year we had lots of hot days, and well, I won't say more about that. But the equation can be used to show a general trend in the pattern of the high temperature over a period of a year without being held accountable for predicting the exact high temperature for a given day. This is an example of an interaction between a deterministic process and a non-deterministic process. I can get general patterns, but I can't be ultra specific at a particular point in time. I can say, you know, this plus or minus 2 standard deviations. I can probably say something like that. But nobody likes that. Okay, so despite precise mathematical models, just one change in one factor can change the direction or severity of a storm, hurricane, tornado, or the likelihood of a sunny day when you go to the beach. Very important. Okay, what's the moral of the story? We can study individual factors affecting weather and describe them by precise mathematical equations. That's an example of a deterministic model. But we can also see that those equations involve parameters that are fairly small, that with a fairly small change can yield an answer quite different from what we expected. That's an example of a non-deterministic model. So is this an example of chaos, or is it an example of God's wondrous creation? There you go. I think that's it. Is that my last slide? Yay! Okay. All right, plenty of time for questions or comments. Yes, Joshua?
Regarding that last question you asked, why can't people I think you call chaos bad, but why?
That's a good question. Yeah, people call chaos, my bedroom was a chaos, or my hair is a mess, my hair is chaos today, thinking that that's not good. But when we talk about chaos in this sense, yeah. Andrew?
So when we're incorrectly using words like random and chance, what should we use instead?
Well, you should be more precise. Okay. What was the chance that I would stub my toe and break my toe? Well, given the way I walk, it was a pretty high chance, but maybe over enough times if I go past that bedroom post, I'm going to stub my toe and hurt it. So, I could think mathematically and say, there's a 50% chance that one of these days I'm going to break my... But most people don't think that way, do they? They just think, well, it's chance. Or, yeah. So I would want people to be more precise in their language. I tell my students all the time, this is not a very precise statement you made. You need to be more precise. Geraldine?
So are you saying that there can be chance in God's world? That God doesn't have everything all worked out exactly?
I don't say it that way. I say that God created the world and the universe so that there's chance and randomness built in. And there's a famous scientist, maybe I don't know who it is, who said, God not only throws the dice, but he throws it into a corner where you can't even see, where he can't even see it. So,
He can't even see.
to where he can't even see it. Yeah, so I'm not going to go that far, but I'm going to say I think there's enough randomness built into his creation. He deliberately built. Well, and the advantage of that, he's a pretty smart guy, I think. The advantage of that is that, is this. And Katie's here, she's an ecologist, maybe she can help us understand here. You need to have physical systems that can adapt, that can change. And if they don't, they die, they get extinct. So what accounts for that? Well, I think randomness accounts for that. Some built-in randomness. Some built-in ability to change. You're thinking, aren't you? Yes, sir.
How do you think that the climate change that we're seeing happening will be taken into account in the numbers that they already have, the techniques that they already use? How will that be?
Well, that's a good question. That'd be a Dave Andrews kind of question, wouldn't it, on Weather Wednesday on Channel 6, where they're talking about weather change. There are things that they're talking about whole sections of the country changing from temperate to desert, and the water systems changing. So the models will have to take that into consideration. Those guys who are paid to be bucks to deliver those models are going to have to take that into consideration.
So it's the model that'll have to be.
Yeah, it's the model that, Matt?
Given the slope fields and differential equations, does that, in essence, provide that chance that you were talking about? Because when you're talking about the hurricane influence and it's going to hit this area, but because you can say on a coordinate system, because they didn't know the constant in many different ways, they took the origin of this sort of graph that the hurricane took is going to go, it's going to start here, we just don't know if it's going to go this way. Could that be the same way how slope fields are set up?
I think so, because on one of the Weather Wednesdays on Channel 6, David Andrews was showing exactly a slope field. And you have all these little tangent line segments that helped show where they thought the hurricane was going to go. Yeah, that's a great example of vector calculus.
Can you give him an extra point in whatever class he's in?
I probably have to.
Wow. Yeah.
That was great, wasn't it?
No way.
He's in one of my classes.
So I have a rhetorical question.
Last night, I was listening to the TV, and it was for an insurance company, for life insurance or health insurance. I think it might have been State Farm. And he said, well, what's going to happen? Because we have all these floods, and they're called 500-year floods.
But they're happening
We've seen
every
30 500-year floods. So that's
Yeah.
bad. Does anything that you've presented today have an impact on?
Well, that's related to John's question, was that systems are changing. They're dynamical systems, and they change. So somehow or other, we have to figure out models that will help us predict, if possible, these once in every 500 years. I mean, we've had enough of them happen just since Katrina that we're thinking, wait a minute, there's something going on here we need to investigate further. But yeah, I'm guessing there's people, I'm guessing the weather modeling people are hiring some more, they're actuarial scientists and computer people, yeah, to say, wait, there's something, yeah, we need more data here, and we need to get going, yeah.
Another question. So would you say there's a hard line between random and there's so many factors that we can't figure it out?
That's a good question. This is sort of related, I was going to say it's related to the board that's already over there on the problem board, and you introduced some complexity, thanks a lot. Yeah, it really makes you, wow, so many things I want to say. Yeah, if there's a million different possible things that can happen, that makes you just go, well, whatever. Something's going to happen, and I need to prepare as best as I can for these different events. Or you might have clusterings of events, okay? If my TIAA, what can I do to my TIAA craft account? You don't know what that is, Dave. I'll look at.
I do.
Okay. What can I do? I made this decision back in 2013. What can I do to my TIAA craft account to minimize the loss if we should have another 2008? So I talked to my guy about it, and we made some changes in my account. That doesn't mean I won't experience any loss, but it won't be as big a loss as Bruce is going to have on his account because he doesn't have it moved to a more conservative fund. Yeah, so my advice to people is think about the different things that can happen and prepare as best you can for those things. I'm always amazed at the number of people who know that a hurricane is headed for their house and they're going to, quote, ride it out. I go, you have got to be kidding me. Now maybe maybe they don't have transportation, I don't know what else, but I'm loading up my car, I'm putting my computers and my picture albums, I'm getting the heck out of town as fast as I can and go stay with relatives in Illinois. That's what I'm doing. Yeah, so, but my main story would be, you need to think about what are the things that can happen and realize that any of those things can happen and prepare as best you can for them. That's what you need to do. Yes, Matt. Oh, is it going to get another point in vector calculus?
I was just thinking, I don't know if you covered this already, but does the central limit theorem establish order in the chaos of the world?
The what? Central limit?
The central limit theorem establish order in the chaos of the world?
I don't think it establishes order. I think it describes order.
Because when we had the Excel spreadsheet, it was all, you said all those things were different, and
where are we? Okay.
Different individual ones, you only had 10 numbers, and then you went to the 300, and it was closer together than when it was smaller, and so that's kind of what the central limit there is stating. So
yeah, the larger the sample size.
In the end, as you add more and more to it,
yeah,
it's going to be more orderly.
Yeah, the central limit theorem says the larger your sample size, the more you should see the pattern that you expect to see. But even with 1,200, we weren't getting exactly the pattern we expected to see, were we? So there's still some randomness going on there. Yes?
Jim thinks that Andy Provenzano should have gotten some PR too.
Oh, boy.
I know you came to consumers.
Yeah. Yeah.
I like Jim Cantore.
Oh, yeah. They're all good, aren't they? Yes.
Well, biblically, how do you resolve the difference between the hyper-Calvinists and the hyper-West?
Oh, my word. Well, I think there should be, okay, hyper means one's way over here and one's way over here. So, I'm going to stand right kind of in the middle and say, well, yeah, but, I'm going to do that. I'm a big weasel person. Or my dad was great. If he was talking to a Republican, he would advance the Democratic argument. If he was talking to a Democrat, he would advance the Republican argument. He played that well. So I think I learned from him. Yeah.
So is salvation random or determined?
Oh, wow. I'm reading a book called The Sin of Certainty.
Sin of certainty.
The Sin of Certainty. And Geraldine put me onto it. And in one of the chapters, he talks about, am I a Christian simply because I was born in a particular place, at a particular time, in a particular family, in a particular community? And he says those are things that we need to think about when we're dealing with people who weren't born in the same environment we were born in. And those are big questions. No answers, just questions. Yes, Josh?
I would say that if we look at the definitions you gave earlier in the slide, there's multiple possible answers, so that would...
Wow. Yes, thank you. Well, if you just look at Protestantism, let's not wander too far away from there. I mean, Luther really opened a can of worms, didn't he, when he said, hey, you ordinary people, you can read the Bible and interpret it for yourself. So we did, and then as a result we have, how many different sects of Protestantism do we have? Because people interpreted different scriptures differently than these people over here. And for us, sitting in this room, we probably have 4 or 5 different versions of Protestantism, maybe more than that in this room, but we're not trying to kill each other, are we? But they were, okay, Tim says, maybe we, but in those days they did try to kill each other. They did successfully kill each other. It was deadly serious to them. You don't interpret it the way I do, so we're going to burn you at the stake. So, but I'm not answering your question, am I? I was wandering all over, hoping an answer would come to me. But yeah, there's different, I think God really, he just laughs sometimes, just has a big old belly laugh sometimes when we're arguing about this particular verse. What does it mean in the Bible? He's probably just saying, oh, for Pete's sakes, focus on first principles, would ya? Yeah.
I think there are about 300 different kinds of denominations.
Oh, you're helpful. Thank you. Well, there's probably 6 different types of Lutherans, I think, even in the United States. Yeah, okay.
There's 3 different branches of Lutheran.
A Lutheran, okay. Yes, ma'am.
So, is your conclusion that indeterminism and determinism are like intertwined and reliant on one another?
Oh, I think that's a wonderful way to say it. I would say that the physical world has built into it deterministic processes and non-deterministic processes, and sometimes a given process has both elements in it. And I don't think that's something I'm afraid of. That may be indicative of chaos theory. I don't care. I think that's the way God created it. Yes, ma'am?
Could you describe chaos as living with unknowing, with not knowing what? With not knowing what those probabilities could be?
Yeah. Well, there's several different ways of not knowing. 1, not knowing even what the possible outcomes are going to be. 2, not having a pretty good idea what the different outcomes are, but not knowing what their individual probabilities are. We tend to think sometimes that each possibility has the same probability as any other possibilities, but that's not always true. Or 3, you kind of have a pretty good idea, but still you got to prepare for several different possibilities. I don't know if I even addressed your question, but I loved what I just said. It was so cool. But my problem with ordinary people, not you of course, but not or anybody in this room, is that they're not even thinking about those possibilities. We had a teenage daughter who wasn't thinking about the possibility she was going to get pregnant if she had sex often enough over a long enough period of time. And when she got pregnant, she goes, "How did that happen?" And I go, "Are you kidding me?" But these are teenagers, and how many teenagers? No, I'm not going to ask that question. Yeah, so maybe, yeah, I shouldn't have gone there. Maybe that's part of my problem, is that I'm on the benevolence committee at our church. So I'm surrounded by people who are not even thinking about what could happen if this. Who are not planning for any contingencies.
Well, I guess I was thinking more in terms of perhaps evolution or the age of the earth.
Oh.
And that sometimes, we want to know these things.
Yeah, right.
We want to know, how did God create?
Yeah.
And sometimes we just cannot know that.
Sometimes your kids cannot know.
And it's not, in a way that's a chaotic.
Yes, it can be chaotic.
In a way that's a
comforting.
Non-chaotic
Yeah.
thing. Okay.
Right. Well, in the book that you and I have been reading,
Yes,
he addresses a little bit of that. And he doesn't say this, but when I read that chapter, it said to me, I don't know how God did it, but I know he did it. And I take some comfort in that. Now, if other people want to argue about how he did it, I think even among our own university here, we have differing opinions about that. And what I like about our natural science folks is we can talk to each other without hitting each other over the head and saying, you're wrong, you know where you're going.
Right.
Yeah. Even politics, yeah. So, even politics. But, I love to look at the data, and there are some books that we have read. Let's see, Coming to Peace with Science is a great book, and I'm sure that Katie and others have books that cause students to think, wait a minute, maybe I need to open my mind a little bit and allow for some other possibilities. Under the rubric of, in Coming to Peace with Science, there's 3 different theistic points of view. And to understand that they are theistic points of view. They're points of view that say, we don't have all the answers to how God did this. We know he did it. Here's some data that might imply this. So let's think about that. Yes, sir. This handsome man here is my husband, by the way.
Oh. We know he did it only by faith. We can't prove that he did it.
No, that's not.
There's just no proof.
Yeah.
God has not given us proof.
Yeah. It's like statistics. You can collect data, but you can't necessarily provide a mathematical proof. You just collect data and say, here's some data. Where do we go with here?
There's always those outliers.
Outliers, yeah. Those outliers get you every time. Okay, what else? Great questions. Good thought-provoking questions.
Are there any volume events to which the, now I've forgotten the term you used, the central limit theory does not apply?
Probably.
Well, isn't that, don't you have to have a random selection of things?
Yeah.
Things have to be random?
Right.
In order for
Right.
the central limit theorem to apply?
Yeah.
It has to be a
Yeah, underlying.
prior.
Right.
And I'm not sure I'm stating that.
Now, the different versions of the central limit theorem I have seen always start with, you got this big population you don't know anything about. And from it you're going to take a sample. Now if you take a small sample, and then you take a larger sample, and then you take an even larger sample, and keep on doing that, then the properties of this sample will eventually look more and more like the population. And it could be applied to the mean, it could be applied to the type of distribution, it could be applied to the variance, it could be applied, yeah.
And
So
it's how you draw that sample.
Yeah.
If the sample is drawn at random,
at random, yeah,
then the central limit theorem can apply.
yeah. There's
It's
a,
interesting because the central limit theory applies to large numbers
that's right.
that are inherently random, or you don't know enough about to know that they are determined.
Yeah, yeah, yeah.
It doesn't apply to things that are determined.
Right, exactly.
It seems to suggest eventually there
We'll know enough that everything will be deterministic? Ooh, that's a good question. I don't know, we're still rolling die, and that's, that's 1 out of 6. Come on. Great questions. Any more? I won't be able to sleep tonight. Yes, sir.
I'm always impressed by the fact of what chance we had of being born in the United States
Oh, yeah,
as
yeah.
opposed to anywhere else in the world. It's a very small chance, apparently.
Yeah. And as a female, I'm really glad I was born here and not Saudi Arabia or, I'm sorry, other places. Yeah, other places.
I think
Africa.
maybe even more intriguing is the chance that we were born at all.
Well, yeah.
Okay.
You care to say any more about that?
I think those who have had biology know where I'm going.
Oh, okay. All right.
If you've ever seen a birth happen, which I did, you wonder how any of us were ever born. It's near miraculous.
Yeah. You don't have to go back very far. Let's see. The book I just finished reading, the novel I just finished reading, so back 150 years. And in the book was a woman in the northwest of the United States who had about 10 children, had 10 pregnancies. 5 of them resulted in miscarriages. 2 of them resulted in stillbirths. And then she had 3 children that survived. That, wow, we don't do that. I mean, in this country today, that would just be considered horrible, unacceptable. Our system wouldn't want that to happen. No.
But a factor like a contaminant in the water
Yep.
could account for something like that, even in this country.
Right.
It has.
And they may not even know there's a contaminant in the water. Yeah. What is she pointing at?
She said that you can't see lead.
We discussed the Flint water crisis.
Ah, the Flint water
chemistry
crisis.
seminar.
Okay.
So
Yeah.
there are a lot of things you can't see.
Yeah, that are bad for you.